The poet Joseph Addison once said that our sight is the most perfect and the most delightful of all our senses. The goal of computer vision is to build machines that can see. We have already witnessed some very successful applications of vision, such as face recognition and driverless cars. There is much more to come. In the next decade, we can expect computer vision to have a profound impact on the way we live our lives. The goal of this lecture series is to cover the mathematical and physical underpinnings of computer vision. Vision deals with images. We look at how images are formed and then develop a variety of methods for recovering information about the physical world from images. Along the way, we show several real-world applications of vision. Now, since deep learning is very popular today, you may be wondering if it is worth knowing the first principles of vision, or for that matter, the first principles of any field. Given a task, why not just train a neural network with tons of data to solve the task? Indeed, there are applications where such an approach may suffice, but there are several reasons to embrace the basics. First, it would be laborious and unnecessary to train a network to learn a phenomenon that can be precisely and concisely described using first principles. Second, when a network does not perform well enough, first principles are your only hope for understanding why. Third, collecting data to train a network can be tedious and sometimes even impractical. In such cases, models based on first principles can be used to synthesize the data instead of collecting it. And finally, the most compelling reason to learn the first principles of any field is curiosity. What makes humans unique is our innate desire to know why things work the way they do. I have partitioned this lecture series into 5 modules, each spanning an important aspect of computer vision. To take any of these modules, you don't need any prior knowledge of computer vision. All you need to know are the fundamentals of linear algebra and the fundamentals of calculus. If you happen to know a programming language, that would enable you to picture how the methods I describe can be implemented in software. In short, I believe any science or engineering sophomore should be able to handle the material with ease. Now, while we approach vision as an engineering discipline in this series, when appropriate, we make connections with other fields, such as neuroscience, psychology, art history, and even biology. I really hope you enjoy the lectures, and by the end of it, I hope you will be convinced that computer vision is not only powerful, but also fascinating.